Hello, everyone. Thank you all for joining our webinar. My name is Sana. I'm a field application engineer at MultiLane, and joining me is Vincent Liusi, who's also a field application engineer at MultiLane. So Vincent is based in Fremont, California, and I'm in Beirut, Lebanon. So we're going to do this webinar to go over MultiLane's interconnect products. You know, MultiLane is a leader in the interconnect business. So we're just going to go over our best products and what we're working on now and where we are headed. So we're going to focus on our 800 gig interconnect products and their applications. So I'm going to share my screen. Before we start, if you guys have any questions, feel free to drop them in the chat box, or we can leave them till the end. We're going to have time for every question. There's going to be a live Q&A session, so we're going to answer all your questions. So here we go, MultiLane Interconnects from A to Z. We're going to start by introducing the company and then talk a little bit about our signal integrity expertise before introducing our different products and their different applications. And then we're going to dive into our 800 gig interconnects before finishing off with a live Q&A session. So MultiLane was founded in 2006 by our CEO, Fadi Daw, in Lebanon. And since then, MultiLane has seen immense growth, particularly in the interconnects business. We have grown to become the #1 supplier of compliance boards to the data centers industry market, as well as the #1 supplier of high-end, high-performance loopbacks to system vendors and hyperscalers. We are also major contributors to standard bodies and the OIF. MultiLane has a global presence, so currently we are headquartered in Lebanon, and we have an office in Fremont, California, offices in Germany, China, and Taiwan, and we just opened up an office in Dubai. So it's an ever-growing company. We work with more than 500 customers, and we have more than 200 products released, which support from 10 gig to 800 gig. So before we talk about what we're working on now or what we're going to work on or where we are heading as a company, we want to talk about the journey that got us to where we are, how we became the #1 supplier of interconnects to the market. So we started shipping our first interconnects back in 2011. And since then, after a lot of success with our custom loopbacks, our customized loopbacks, and then a lot of success in the QSFP-28 standard in terms of fixture deployment for 100 gig, and then with PAM4 and with 112 gig deployments, we have crossed the threshold about 2 years ago of sending more than 4,000 loopbacks every week. And with the industry moving towards 800 gig, to be able to test to enable testing for 800 gig ecosystems, you really need a mastery in signal integrity, which is a principal focus at MultiLane. So since 2019, our SI team has grown by 300%, supporting 19 different MSA Form Factors with more than 15 112 gig products released and more than 20 112 gig products under active development. So our interconnect solutions range from compliance boards to loopbacks to adapters and analyzers, and I'm just gonna give a quick overview about each of them. So just to recap, we have our host compliance boards, our module compliance boards. We have 3 types of loopback modules, so passive loopbacks, active loopbacks, and lost target loopbacks. And then we're gonna finish off with our adapters and analyzers. Our solutions and products support these form factors. So we have from CFP to CFP2 ACO and DCO, all the way to QDD 800, OSFP, OSFP 800. And in the coming year, so in 2022, we're going to release products in the new OSFP XD form factor. So we're going to start with our loopbacks. A loopback will loop back the TX of your port signal to the RX path. They are heavily used in switch design, validation, production, and deployment. A loopback's most important function is that it emulates the behavior of real transceivers. So if you have a transceiver that you want to plug into a port, you can use our loopback to test the link performance of the port, or it can emulate the thermal behavior of your transceiver. And an example of such a loopback would be our ML4062 TL2A, which exceeds 23 watts in power dissipation. So it would, emulate the thermal behavior of a transceiver that you have. And so to recap, it tests the port signal integrity, the thermal dissipation, CMIS compliance of hosts, routers, switches, transponders, server NICs. And I want to say that our loopbacks are customized, and our most successful loopbacks are our customized loopbacks. So MultiLane will customize anything from the color of the latch to the power dissipation that you need for your application. Just ask and we got you. For our host compliance boards, HCBs or Breakout board, so it's a breakout tool to test the electrical path of hosts. It's a passive structure that maintains the best signal integrity. So also it tests the electrical paths of hosts, of switches, routers, transponders, server NICs. And in briefs, what it does is that it ensures that the output signal of the host is clean enough, while ensuring that the input signal into the host can be recovered if there is high jitter or noise. Moving on to our module compliance boards, I just want to remind you that if you have a question while we're presenting, please feel free to drop them in the chat box. So moving on to our module compliance boards, if you have any form of pluggable, you'd need an MCB to test it. What an MCB does is that it initializes and reports your module diagnostics. So whether it's temperature, current, voltage, or power level, you will need an MCB to kind of monitor that or see those reports. An MCB enables reading and writing to the module EEPROM, so it will give you access to that. And you use an MCB to test any type of pluggable, more notably like optical transceivers, active copper cables, active optical cables. And in brief, what it does is that it provides an input signal access to test that a module can deliver a clean output signal. And you can also use it to stress test your module. So it really just depends on your application. But once you get an MCB, you will have access to our CMIS GUI. So CMIS is the Common Management Interface Specification. It's a set of rules for the management of advanced pluggables. It's very user-friendly. All our GUIs, for that matter, are very user-friendly, very practical, very straight to the point, as I think you can see a little bit from the screenshot that we have on the slide. So this GUI supports CMIS 3.0, 4.0, with CMIS 5.0 under development. So as CMIS is constantly changing and evolving, so is MultiLane. So through the GUI, you will have access to module diagnostics. So again, temperature, power, current, voltage, you will be able to monitor all of that through our GUI. You will have access to the module EEPROM. You will be able to read from or write to the module EEPROM. You will have access to the low-speed signals. And we are very excited to say that we also have a new feature on our CMIS GUI, which is the new Common Data Block Dashboard, CDB. So CDB is a message communication protocol between the host and the module. Now, its most important function would have to be that we can finally debug and upgrade module firmwares solely through this GUI. And so it issues CDB commands from MCB to the module, and this feature supports CMIS 4.0 and 5.0. CDB is available on most our 400 gig and 800 gig MCBs, specifically on all our 4062 MCB variants, which is our QSFP-DD form factor MCBs. So this license will be available for purchase with whichever board is of interest to you. Again, I just want to note how practical and straightforward our GUIs are, as you can see again from our screenshots on the slide. Last but not least, we have our adapters and analyzers. So our ML4066 adapter and ML4066-ANA analyzer. So an adapter is a passive interconnect with low loss, which provides a high-speed signal from module, a high-speed connection from host to module and vice versa. And it has hardware control pins on the board, which can be probed manually, or even better, can be accessed through our analyzer board, which will mate onto the adapter board. And once you mate the analyzer onto the adapter, which takes like 2 seconds, it's very practical, very easy. It takes like 2 seconds, you will have access to our CMIS analyzer GUI, and you will have access to these control pins through our GUI. I will get to that in a second. I just want to say that our adapter and analyzer are available in QSFP, QDD, SFP, SFP-DD, and OSFP. So back to our very comprehensive CMIS analyzer GUI, a very high level GUI. So, once you have access to this GUI, you will be able to monitor the I2C communication between the host and the module. You will be able to capture I2C packets and analyze them and basically visualize all this, this communication on your screen. And then you also have a state machine test, which is what you see on the screenshot right there. And you will also have access to module EEPROM for sure. And our GUI enables testing in 3 modes. So we have initiator mode, where the module acts as a DUT while the analyzer acts as a host. And then we have the target mode, where the module acts as where the switch acts as the DUT and the analyzer acts as the module. And then we have the bypass mode, where you can monitor the host to module link or connection. So, and our analyzer and adapter are used to test, all hosts, again, server NICs, switches, routers, any type of host, and also, optical and electrical modules and cables. So again, I hope that you can see from the screenshots how practical and straightforward our GUIs are and how comprehensive they are. They are very high level and yes. So we are going to start with our 800 gig interconnects, and I'm going to give the floor to my colleague Vincent. So Vincent, go ahead, take it from here.
Thanks, Hannah. Before I jump into the 800 gig discussion, I would just like to, I've seen a couple of people have joined since we first started. We do have a Q&A section, which a button in the webinar so that you can ask any questions you may have. So if you have any questions while we're talking, go ahead and put them in there. We will also, answer some questions live at the end. So in the Q&A, we currently already have one question, which I will get to during my slides. So I'll answer that live. And then additionally, at the end, we will have a live Q&A. So feel free to drop any questions or wait to the end and ask them then. So talking about 800 gig interconnects, we want to focus on this because we know many of you are working on 800 gig designs right now or producing your 800 gig designs. And those of you who aren't are probably already looking at your 800 gig designs, and we want to support that with our 800 gig interconnects. But before we get into the interconnects specifically, I would like to talk about the complete 800 gig ecosystem. At MultiLane, we have solutions for the whole ecosystem, and that starts from many of the interconnects, such as the MCBs and the HCBs that Sana mentioned, and also the passive loopbacks, which we have for 400 gig, 800 gig, and all previous rates, as well as some new products such as the active loopback and the loss targeted loopback. And moving beyond interconnects, we also have 800 gig BERTs for 800 gig solutions, and even an 800 gig BERT that we will come out with an integrated MCB. So you have the MCB functionality and the BERT functionality all in one box and one GUI. And on top of that, MultiLane, we also have solutions for digital sampling oscilloscopes for 800 gig, as well as the ML4035, which is a piece of test equipment that works for TDR and COM measurements as well. So we do have solutions for the whole 800 gig ecosystem, which are really enabled. The backbone of that is our 800 gig interconnects. So starting on the 800 gig interconnects, I'll talk about the 800 gig HCB first. And that leads us to one of the questions that we got in chat is, what's the difference between QSFP-DD and QSFP-DD 800? So for 800 gig, we have form factors of QSFP-DD 800 and OSFP 800. And the difference is QSFP-DD 800 and OSFP 800 have improved signal integrity that fits the specs for 112 gig electrical per lane. So that would be compliant with the 802.3 CK spec, as well as the CIE 112 gig VSR PAM4 spec, and even the CIE 56 gig NRZ VSR spec. So it's improved SI design to be compliant with 112 gig per lane. And this also makes it inherently backwards compatible, as you could also use a lower line rate there. But the SI is optimized for 800 gig and 112 gig per lane. So as Sana mentioned already, the HCB is for breaking out the high-speed host electrical signals. And this allows you to test those electrical signals from a host. And for our OSFP 800, and QSFP-DD 800, this is 8 by 112 gig per lane. For OSFP, we have a single board. And for QSFP-DD, we have a 2-board pair so that you don't have a bulky assembly and you can plug in multiple HCBs to a host. As you can see on the right on these slides, we have on top, we have our OSFP insertion loss S21 graph here. And we also have the QSFP-DD insertion loss graph. And you can see we really have high quality signal integrity, which ensures low loss and allows for strong signal fidelity. And the reason this is important is you want to accurately model and test your 800 gig host system, and this low loss and high SI performance really enables that. So to show you how a 800 gig HCB would be used in an environment, we can take a look at an example. So for this example, the test device is an 800 gig switch, and in this picture we have plugged in an OSFP 800 HCB, and then we have that connected to an 800 gig BERT, which is one of MultiLane's other products. And with the 800 gig BERT, with the OSFP 800 HCB, we get access to all the high-speed signals. And connecting the BERT, we can check both the transmitter and the error detector of the switch. So we can input signals and we can get the BR out from the switch. We can also take the signal from the switch and use equalization on our BERT to take a look at the bit error rate. And this is where the high SI performance becomes very important, because when you're plugging in as a user of the HCB, you want to be sure that you get strong performance and low loss in the HCB, so that the measurements you're taking on the BERT or whatever device you connect to this HCB is actually the performance of the switch itself. And you're not getting a worse performance because of the HCB. And because of our low insertion loss, you can see that the performance is really going to reflect what you see in the switch or the host system. And that's going to give you high confidence on your product's performance, which is very important. Instead of a BERT in this scenario, you could also plug in, for example, a DSO, and you could take a look at the eye diagram. For our HCBs, we provide the S parameters. So if you're looking at an eye diagram, you could even use a de-embedding filter to de-embed the loss of the HCB and take a look at what the eye looks like exactly at the transmitter of the port. Or as well, you could plug in a different instrument such as the ML4035, which would allow you to take TDR and COM measurements. Another one of our important 800 gig interconnects is the MCB, the Module Compliance Board. This also comes in the QSFP-DD 800 and OSFP 800 form factor, and is also compliant with the 802.3 CK specs, as well as the CI VSR specs as well. And as Sana already kind of talked about, the what you can enable with the MCB in terms of the CMIS GUI. You can write I2C read-write commands. You can load MSA memory maps. You can use CMIS validation features, and we have CDB enabled. And this is compliant with, CMIS 4.0 and 5.0. And again, similar to the HCB, we are enabling the testing for this time for the transceivers, AEC, ACC, DAC, and other modules via the breakout of the high-speed signals. And the insertion loss, the high SI performance, and the low loss is very important to make sure that you get a measurement that is reflective of your device's performance. So looking at an example of the MCB, 800 gig MCB in action, in this picture, I have the QSFP-DD 800 MCB, and I have plugged in a transceiver, and then I've connected the high-speed signals to an 800 gig BERT. Now this will let me do, testing of this module, this transceiver, and do TP1 testing and that. And if you are, let's say, using a cable instead of a transceiver, you could duplicate this setup. You could take two MCBs and two 800 gig BERTs, and then you could get a bidirectional test of your cable. And so the 800 gig MCB really enables you to test any pluggable, as Sana mentioned, and the very high performance at 800 gig can give you confidence that you're going to get strong results from your device and low BER, which will give you confidence then in your product and allow you to take accurate test measurements. You can also use, for example, this setup to drive the transceiver if you're using an optic and take a look at the optical signal on a DSO as well. And you can use other instruments to do other tests, such as, doing a COM measurement over a DAC cable if you plug in, an ML4035 with that capability. So for our 800 gig HCBs and MCBs, we also have a form factor with MXPM70 connectors. So this is the same form factor as the others with QSFP-DD 800 and OSFP 800. And similar to those, it has the high performance SI. As Sana mentioned, we have a very strong SI expertise, and these are still in compliance with the specs, the 802.3CK and the CEI. But the main difference here is this has two Huber-Suner 2x8 MXPM70 connectors. And these are block connectors that can be easily connected to the MCB/HCB. So if I go back a slide, you can see that there's a lot of connections to do the electrical breakout on this MCB. But with the MXPM70 version, it'll be a quick and easy connection and save you a lot of time while still maintaining that high performance. If we look at the S21 plot in the bottom left, we can see the insertion loss, and we can see at Nyquist, our loss is about 2.1, 2.2 dB, which is still well within the spec and a very low loss, low insertion loss. As well as, these Huber-Suner connectors and cables can be de-embedded during a compliance test so that you can de-embed any loss that's there. Another important board that MultiLane has for 800 gig is the channel emulation board. So the channel emulation board has multiple different paths, from 2 dB, passive ISI loss paths. So from 2 dB all the way up to 24 dB in 2 dB increments with very high signal fidelity. So you can see in the trace losses, the S21 plot in the bottom right, we have very strong performance on those 2 dB steps all the way up to 24 dB. And what this allows you to do is characterize the equalization capability of active DUT designs. So you can place this passive loss path in serially connected to your DUT and see, can the DUT compensate, can the equalization take care of, that passive loss? It allows you to emulate that ISI loss. And if it can, it makes you confident in your DUT's performance. This also allows you to characterize the equalization capacity of 53 gigabaud chipsets and, emulate a series of different passive loss paths. As with all our boards, the HCB, the MCB, the channel emulation board, we provide the real S parameters for this board so that you can use those to de-embed as well. If you do desire to take a look at those S parameters or de-embed them from your system. Now, moving on from our boards, we also have the loopbacks, and those are very important at 800 gig. So the first one I want to talk about is the passive loopback. Santa already kind of talked about this, but I will kind of go over it again and show you why it's important for 800 gig ecosystem. So our passive loopbacks support all the key MSAs, and as Santa mentioned, this is a core product for us at MultiLane. We are the leaders in the industry for these loopbacks. And you know, we ship over 4,000 of these weekly. One of the key features of these passive loopbacks, which Santa mentioned, is the programmable thermal loads, which will allow you to replicate the thermal behavior of real optics at a lower price point. And so what this allows you to do is, if you look at the switch we've highlighted on this, you know, rack on the right, let's say this is your device, you can plug in these passive loopbacks and have their thermal loads programmed to emulate a specific, you know, vendor's optic or device. So let's say you have vendor A, you can, and you know your switch is going to have vendor A optics all in your device, and you want to make sure it's going to be able to handle the thermal load. You can program these modules to emulate, you know, vendor A's thermal behavior, plug them into your device, and be confident in your results. Then let's say you find out that you're also going to have vendor B's optics in your host. Well, you can reprogram these same loopbacks to vendor thermal profile that matches vendor B's performance, and then check that as well as intermixing some of them, vendor A, vendor B, and this will allow you to thoroughly test your host system and be confident that you'll be able to, you know, handle that thermal load in a data center application. You know, loopbacks also are very good for quickly testing and debugging a failing port. For example, you know, you have a failing port, you unplug the DUT, you insert a loopback, and you can quickly find out whether, you know, the port going down was the fault of the DUT or the switch port. So you can plug it in, see, you know, run your port diagnostics and see whether you can, you know, get link up, okay, the port is good, or, you know, it's the DUT problem, or you see the port's still down and you know you have to debug something on your port. This is really useful in both lab use or mass production use, as it's a quick check and will save you a lot of time debugging with a real DUT. You know, one of the key pieces of the passive loopback is that it emulates DUT devices at very well at a fraction of the price. And you know the performance is guaranteed. With our strong SI expertise at MultiLane, you can be confident that our loopbacks are going to perform well. And as Santa mentioned, all of our passive loopbacks and loopbacks have, you know, EEPROM mapping so that you can load custom MSA profiles. It has the alarm and control signals, so it behaves like a DUT. You can also read the temperature values, as well as, you know, I mentioned earlier, program specific thermal loads. And you can even have, you know, we fully customize these. So we can deliver these loopbacks to you with custom thermal layouts, custom insertion losses, and these custom EEPROM values that you can use for a host firmware test. And this means you can very closely align these loopbacks with whatever DUTs you expect in the real environment and be confident in your testing results. Now, passive loopbacks are somewhat limited at 800 gig. At 800 gig in many host environments, you expect to be plugging in active devices. So looking at what a passive device's performance is isn't necessarily enough. So we also have active loopbacks. These active loopbacks are DSP-based loopback modules, and we have multiple DSP vendors supported. And these are ideal for high loss port validation, or any ports where you expect to be using active devices. If you're going to be using active devices in the data center, you want to be using active devices in your test. And that's what the active loopback is perfect for. It allows for host to module link training, you know, for example, FFE tap calibration. And this is because the active loopback enables the retiming and equalization of the host signal. So the active loopback has a PRBS generator and an error detector. So this can support a BERT test, and it can also validate the port performance with an active device because it behaves as an active device. And this is going to have improved performance over passive devices and show you how the port will perform with those active devices and DUTs you're going to be using. And these high loss ports and a lot of these 800 gig ports require the retiming to recover the link. And so active loopbacks are not necessarily, just helpful, they're required in many applications. And our active loopback also supports, we have if you can see this picture of the module here, there's a USB-C plugin at the front of the loopback. And so you can plug into the active loopback and you will get a full BERT GUI for advanced BER measurements with equalization control and CMIS testing as well. And these active loopbacks also have, the added features from the passive loopbacks of programmable EEPROM and thermal power dissipation. Now, on top of the active loopbacks, another important loopback we have is the loss targeted loopback. This is an electrical passive loopback module, designed for 800 gig, but this passive loopback is for a specific targeted loss and has the same signal integrity and same performance. This means the same COM, the same S21 and S11 profiles as an 800 gig DAC. So this is very good for validating your 800 gig port that's designed for passive copper DAC pluggables without having to use the heavy, expensive DAC in your production test. So for example, you're trying to do the production test for this device. You're not sure, DAC performances have high variation and are more expensive. So you're gonna have to plug a bunch of these in. You might get, varying results. You can't be super confident with them. With the loss targeted loopback, it's less expensive and it has lower variation. You can plug these right in. It emulates perfectly the COM S21, S11 profiles of the DAC and basically test your whole system as if it was filled with DACs without actually needing to, install, purchase, and use all of those DACs in your production test. These loss targeted loopbacks, come with 6 or 9 dB attenuation at Nyquist, and this is to emulate, 1.5 2-meter DACs. It emulates the specific, as I mentioned, the specific 800 gig DAC loss, reflection, and COM profiles, and eliminates uncertainty in your port test. So that when you run this test with our loopbacks, the loss targeted loopbacks, you can be very confident with your results. And that covers most of our 800 gig specific interconnects. I know Santa gave us a great overview at the beginning, and then we kind of focused on some of the specific 800 gig interconnects that MultiLane has to help any of your testing needs. And if you have any questions, I see some questions in chat. Now is the time. Feel free to keep adding them. We will go through many of them. And we can go back to slides if you have questions on specific slides. And we will start, our Q&A now. So I see a question in chat. Oh, someone answered that. Okay. Someone's asked, does this testing depend on the host system, or can we run any designs to test the functionality? I believe that question is in regards to the loopbacks. And the answer is, for the host system, you can test any host system as long as you have the right module form factor. So for 800 gig, you would need to make sure you have the QSFP-DD 800 if you're doing 800 gig QSFP-DD, or OSFP, vice versa. If that was about a different device, please feel free to chime in with that. What are the advantages and disadvantages of MultiLane 800 gig BERT and other competitors? That's a good question. We kind of focused on our interconnects for this, this presentation, so I kind of flossed over the multi-lane 800 gig BERT. But the advantages of the multi-lane 800 gig BERT is we give you very fine tuning on the equalization on the TX side, up to 7 taps. And we also have noise injection features. And with our integrated MCB plus BERT, we have, a place where you can, a one-stop shop where you can plug in your, pluggable and check very quickly and easily. We have a very powerful GUI. There's a lot more that goes into our advantages over other competitors. I would recommend I can move to this slide at the end. We have our emails available. You can feel free to email us, and I can provide a full list of our competitive advantages and our specs on the 800 gig BERT. I see another person has asked the question, what are the other options to test apart from connecting to 800 gig BERT? So that's a good question, and it depends on what you are testing. If you're testing a host and connecting the HCB, you don't have to necessarily use a BERT. You can use any test device that you want, right? So you can connect a oscilloscope, a DSO, so that you can take a look at the eye coming out of your host. You can also connect, different test equipment, MultiLane, for example. We have the ML4035, which allows us to do, DSO functionality along with TDR and COM measurements. So you can connect that as well. And on MCB, it's sort of similar, but you're going to do that to test the pluggables. So that would be, the transceivers, the DACs, the AEC, the ACC, etc. If I wish to characterize for FEC, preemphasis or equalization, is it possible? Yes. So with the active loopback, I believe this question is regarding loopbacks. With the active loopback, we actually have PPG and error detector in there. So you can actually, go plug it into your host port, see the specific, BR measurement that you're getting out of that, on the receiver of the active loopback, and use that to tune your transmitter, as well as you can tune the active loopback transmitter to check the receiver of your host port. So that's a good question, and the answer is yes. Actually, that's one of the main important features of the active loopback, is that it allows you to characterize the host port and do all of the characterize it for the preemphasis and equalization you will need, both directions. Do these boards work across all wavelength bands, or is there some band specification? I assume that this is for the MCB, and the answer is it works across all wavelength bands. So this is going to be, as long as it's the same mechanical form factor, QSFP-DD or OSFP, it'll work for single mode, multi-mode, DR4, FR4, whatever the application is, 800 gig, 400 gig. Yep. I'm gonna keep going down to more questions. Feel free to keep them coming. And if you do have any questions that are let's say, maybe confidential, you can't share the information in the webinar, at the bottom of this slide here, we have the emails for technical info. You can contact FAE@multilaneinc.com, or you can contact me specifically or Asana specifically at our emails, which is just our first initial and last name @multilaneinc.com. So I encourage you to, ask us questions or send us an email if there's something confidential. How many plugin time is guaranteed of the loopback module to make sure there's no performance degradation problem? That's actually another really good question there. That depends on the connector. That's going to depend on the standard pad spec and connector spec. For the loopback, that's going to be the pad, and the plugin times is going to be guaranteed. We can actually customize it to thicken the gold fingers to have increased plugs, an increased amount of plugs. That's a spec. If you follow up with me for email, I can get you the exact number, but we can actually customize it and increase that plug performance. And we can make sure there's no performance degradation problem, because actually many of our loopbacks have insertion counters, which as long as it's plugged in and the power is on, it will count and tally how many insertions there's been, so you can keep track of, oh, you can go into the EEPROM and read, okay, I've put, let's say my limit is 300, 500 plugs. I'm at 450. So I know I'm getting close to where there may be some degradation problem. And we keep that there for you. What's the insertion return loss that the 800 gig signal quality can be received? So the insertion and return loss profiles of our HCB MCB is going to be on our data sheets. It was in this presentation. If you contact us, we can provide you the data sheets with that information. It's also going to depend on the part number. So the profile for the MXPM70 version of the MCB is going to be slightly different than the precision connector version. In general, all of the loss profiles that we have, we've used these, we tested these, are very low loss, and you can still have very good signal quality through these. And that's actually very important because, as we all know, at 800 gig, even a slightly lossy path, without a ton of loss, a little bit of loss can really degrade your signal. And so you want to make sure it's that low loss. And we can get really good eye diagrams and BR performance, E-12 or better through our interconnects. So yeah, that's a good question as well. I believe some of these I've answered already, so I'm just going to go through and see if there's any we've missed. But also feel free to shoot us an email or keep putting in questions. We'll stay online for a few more minutes here, so that we can get through all of these. Santa, I believe we might have gone through all of them already.
Yeah.
Do you see any others that we're missing here?
No, I think all the questions are covered, but we can stay online for a couple more minutes in case anyone has any question.
Yeah, and while we wait, in case anyone has any more questions, I'd really like to say thank you, for joining this webinar. We really appreciate your time. We appreciate you taking the time to listen to us today, and we hope you've gained a knowledge of how MultiLane's, all of different MultiLane interconnect offerings, and how they're important and can be used in different testing environments and applications. In the entire, not only 800 gig ecosystem, but previous, 400 gig and below as well. How is the interop compatibility performance of your active module of 800 gig? Because the technology is still far from mass production. Yeah, so our active loopback module is the interop compatibility performance is strong. We are actually producing these already, and we have, without saying too much, I can't, under NDA, I can't say too much, but we do have these already available and in customer labs. And if you're interested, we can definitely, you can shoot us an email, and we can definitely talk to you about how we can get you one of our active loopbacks, and you can evaluate it, yourself and purchase some. We're already delivering these and have produced these, and we're continuing to improve upon the, compatibility and usability of the GUI and more as the product matures. That's a good question. I have questions about the thermal load module, fae@multilaneinc.com. Is this the right email to contact as well? Yes, that would be the right email. I'm going to answer that question and leave it answered, so it's in the answered section. I will also add my email and Santa's email. Okay, both of our emails are connected to that one. If you go to the Answered tab, it will be in the text under that question. So if you want our specific emails, you can find it there. On this slide, we also have the FAE@multilaneinc.com. Let's stick around, see if there are any more questions here. And if you had a question that I didn't answer live, we also have our colleague Hanny Dow typing answers to questions in chat. So you can go to the Answer tab and see your question is answered in there if you don't see it in the open questions. We've placed our answers there. We'll stick around for a minute or two more, but it appears that we have answered all the questions so far. Santa, unless you see any that I've missed here.
No, but you did miss an A in my email, but I just retyped my email.
Thank you for correcting that. Yeah. So go check her email again. Feel free to CC both of us or one or the other, and we'll get your question answered. And we're really happy to work with on 800 gig and anything else with you guys. So if you have something you want to talk about, send us an email. We'd be happy to set up a meeting to discuss your specific needs. Application. We're a solutions-based company, so we want to provide the right solution for you specifically. And we're happy to discuss that and learn more about your application and make sure we get you the right tools to be confident in your test and measurement results. Okay, so I don't see any more here. We really appreciate you stopping by. Thank you for listening to our webinar. If you have any follow-up questions, we have the emails. And I believe there will be a follow-up email you will receive after the webinar ends with those as well. Thank you very much for your time, and we appreciate it, and have a wonderful day or evening.
Thank you, everyone, for your time.